Okay. So we had the tan squared minus sine squared equals tan squared equals whatever. So again, in all of these, you should be working with the left side, trying to get to the right side. So I turned tangent in terms of sine and cosine. Then I put sine squared over 1 just to like show that there is a denominator there. So if I was trying to find a like base, what would I do? Multiply by cosine squared. And the left side didn't need anything, so I just kept it the same. I pulled down my minus sign, and then I had sine times cosine, and that was all over cosine squared. So is everyone cool with this?
Yeah.
What would be the next step after this?
That's an
Hmm?
Is that an idea?
We don't currently have an identity. What is the first rule to factoring? GCF. Is there a GCF here?
There's a positive sine squared.
Yeah.
Sine squared here, sine squared here. So if you pull those out and undistribute, basically, you have to make sure that whenever you do that, that if you were to undo what you just did, you would end up with what you started with. I know that was a lot of words to say something very simple, but a lot of the times when you guys are pulling them out, you're either leaving a 0 or you're getting rid of a term completely.
So that'd be 1 minus cosine squared.
Yes. And then,
Your GCF was sine squared.
yes. And now, what is 1 minus cosine squared?
Sine
Sine
squared.
squared.
That's an identity, sine squared. So we, again, had that all over cosine squared. And I wrote these little red dots because we can just pull the cosine squared over, and that gets like used up by the first sine squared. Sine squared over cosine squared is tangent squared. And then we still just have this sine squared. And we needed tangent squared times sine
That's what we
squared.
wrote, but how do you just like separate the sine squared?
So, because since these are both in the numerator, it's technically always sine squared over like 1. So,
So technically it's 2.
because your squared gets used up here, if there was a cosine cubed, it would be like cosine squared gets pulled over here, and then whatever you don't use would be left. So when you pull out a cosine squared to use it as the tangent squared, what gets left? A 1, which is why you just end up with a sine. So this one was kind of difficult because of like the ability to see and do some of that algebra. But sometimes if you don't know if it's valid, as long as you get to this step, just kind of go to the end and then see if it's right, like I can't tell you the number of times I kind of just like faked my way through a trig verify problem, and most of the time it's right. So let me presentation hold, and we're going to move on to the next one, which seemed to be the easiest one. So we had our secant minus sine squared, secant squared equals 1. So I turned secant immediately into cosines, and then I have a sine squared times a 1 minus cosine squared. So my first step that I would do is put that sine squared on top of the cosine squared, and what do you end up with? Over here.
Oh, 1 minus cosine.
If you put the sine squared, it's technically a sine squared over 1.
Oh, okay, then I see.
Yes, tangent squared.
Yes.
So this entire term becomes tangent squared.
Yeah.
So I moved on, and I had a 1 over cosine squared minus tangent squared. Now, this is one of those things that as you're getting more comfortable with it, you might not be able to see, but I knew that secant squared and tangent squared were an identity. So I could have just literally stopped there if you say this is an identity. Or what you guys all did is perfectly fine, and we even saw within that 2 different ways to do it. So you guys all turned it back into the sine squared over cosine squared, found the like bases, we had one group turn the cosine squareds into the 1 minus sine squared, and then we had a different group turn the 1 minus sine squared into a cosine squared. Both of those are absolutely okay. And we all end up in the same place, which is 1. Now down here, I need you all to just like bear with me for a second. So the only Pythagorean theorem you need to have memorized is sine squared plus cosine squared equals 1. You can get to all of the other ones from this.
Wait, what did you say, sine what?
The sine squared plus cosine equals 1, which you don't even have to like really remember because we always know x squared plus r squared or x squared plus y squared equals r squared. With both of these, or with all of these, you can either, what are some ways to change the problem up? You could divide by 1. If you divide by 1, you get exactly what you have here. Divide by sine squared. When you divide by sine squared, you could just write it sine squared over sine squared plus cosine squared over sine squared, but I just drew a big line, so that's why I have these like big circles. But a sine squared over sine squared is what? 1. Plus cosine squared over sine squared is what? Cotangent squared. 1 over sine squared is what? Cosecant. Is this not one of our identities?
Yes.
It sure is. Whoa. Now you know and see where they come from. So let's try it again if we do it with a cosine squared, though, this time. What's a sine squared over a cosine squared? Tangent squared. Cosine squared over cosine squared? 1. 1 over cosine squared is?
Oh, wait, no.
1 over cosine.
Oh, secant.
Secant. That's our other identity.
Yeah.
So that's my fun fact to you, that you can do that. It is possible to only memorize 1. And in a pinch, if you thought you had them all memorized and are like, oh, I remember Miss K doing this thing, you would be able to get to the other ones. So that's the only reason I say that, is because sometimes it's not as easy to see those identities as we're first starting out. But some of these problems you legitimately would not be able to do without the identities. I know it's kind of far down there, but that's the point. This problem, I was kind of shocked that no one got it, actually. What's a secant squared? If it's in the bottom, if it's 1 over secant squared, what do I actually have? You actually have a cosine. You pull it up to the top. So I did hear one group, they got awfully close. It was actually the first group that was there, Jaden's group. They started talking about keep, change, flip, or, well, you guys did that over here too. I pulled the cosine squared up. Down here in the bottom, they cancel, right? And then cosine squared, if I distribute it to the 1, and then I distribute it here, it's literally as easy as that. So this one, you didn't have to use a lot of identities. You literally just had to pull that cosine up to the top. I still see a lot of confused faces.
Well, it's because the equal 1 plus cosine squared. Where did that go?
We ignored it. You have to ignore it.
So we multiplied both the top and bottom by cosine squared and got 1 plus.
Yeah, so if I'm multiplying the top and the bottom is technically 1 over cosine squared. When I multiply the top and the bottom by cosine squared,
That's
this
the same thing.
bottom becomes 1.
Yeah. So.
And then if I multiply the top by it, that's where I distributed it. So I get a cosine squared here. And then if I distribute it here, I get a cosine squared over a cosine squared, which is a 1. And so at the end of the day, I get a cosine squared plus 1.
Oh, okay.
And that is exactly the same thing as 1 plus cosine squared because you can. Yeah.
But what happens to the 1 plus 1 over cosine squared?
That's the only thing that's different.
Here,
Yeah, what happened?
that's
to that?
exactly this. I didn't end up rewriting this
So,
because that cancels to be 1.
Right.
so it's just that over 1, so it'd be.
That. Yeah.
And then what is the cosine squared over cosine squared?
That's-
The plus 1 from the other side?
Yeah.
It's this. This secant squared I changed into a 1 over cosine squared.
Oh, okay, I see it now. I see it.
Yeah.
Yeah, I see that. Because this is verifying.
Yes. Which is why we're crossing out that one side.
Yeah. Okay, that makes sense.
You literally also could have just, instead of rewriting this, you could have said a secant on the bottom is a cosine. So you'll literally just go over here and you'll write cosine squared theta 1 plus secant squared theta. Now 1 plus secant squared could be a different identity, which is another thing the first group, they went down a rabbit hole where they had tangent squared, and I was
Yeah.
like, that is going to be far too complicated. And that's why one of those things is like, you're not wrong for turning it into that, but you're going to end up doing a lot more steps, and you're going to get stuck on problems on the test if you end up doing that. So. This one was just a simplify, and
Is that the same?
no, that's why I said this is just a simplify. So it was that one. This one though,
Is the A the variable?
yes, the alpha value. So that's why I changed it into X for you. You're welcome. So again, if the secant's in the bottom, if I pull it up to the top, what is it? A cos. When I pull that up and it's a cosine, cosine times 1 is cosine. Cosine times cosecant, I don't know what that is, but cosecant is also 1 over sine. So I have a cosine over a sine, which also happens to be a cotangent, which is what we needed.
Man.
So here, I turn this cosecant into a 1 over sine x. So that when I multiply the cosine x in, so again, this is one of those things that you have to practice, because if it doesn't come naturally to you, you will get stuck in the middle of it. There's no way to get out other than to do. You can just keep doing steps, plugging in identities, changing your stuff to 1 minus cosine. I mean, you can do anything to try to get yourself out of a hole, but at the end of the day, if you don't know those identities, you are screwed. And that's okay. I was there once too. Can you imagine trying to do this over Zoom in the pandemic?
You're stronger than me.
I was not. Yeah. Yeah, I was a junior during the pandemic. So I was taking AP Lang, AP Physics, and Pre-Calc online.
Why would you do that?
I don't know. Anyways,